If you've been wondering about what's up with Mars, we've got some news for you. Turns out that sending people to the red planet was a lot harder than we had imagined, and something we'll have to wait for until the 2040s or even later. But until we manage that, NASA is planning on collecting samples that will be brought back to Earth. But how exactly will NASA gain access to them? If you're interested in knowing more about this mission, stay with us till the end of this video. The Mars Sample Return Program has been in the works between NASA and the European Space Agency to bring to Earth the first ever specimens of rock and dust collected from the Martian surface. And if they can manage, hopefully a vial of Martian atmosphere as well. If everything goes according to plan, the goal is to bring the samples back by 2033. Well, NASA's Perseverance rover has been quietly collecting samples on Mars since it touched down there in 2021. Plus, he is getting ready to bring those samples home. No doubt, that would be an exciting achievement for all of us. Once we have access to samples from Mars, we will be able to actually see what it looks like and what it's made up of. And if it's really as red as it looks in the images. But the mission is complex to say the least. There are various steps to put in place that have been laid out so we can let you in on the process as well. NASA and the ESA have planned to return the samples using 3 missions. Engineers have been working to ensure that the rocket's trajectory lines up with that of the spacecraft that will be orbiting Mars. This is important because the sample capsule needs to be transferred to the orbiter. The sample capsule will then be returned to Earth by the orbiter, where researchers would be waiting to safely contain it before transferring it to a secure biohazard facility that is currently being built. The mission would begin with the sample collection mission that relies on the Perseverance rover. Then there's the sample retrieval mission that will make use of the sample retrieval lander, the Mars Ascent Vehicle, the sample transfer arm, and 2 Ingenuity-class helicopters. And finally, the return mission will take place with the Earth Return Orbiter. As you can see, they've got it all mapped out. Once we gain access to the samples, we hope to find out once and for all if Mars ever harbored life. For now, we've deconstructed the expedition step by step to examine every autonomous robot that will have to flawlessly cooperate on a planet that is almost 400 million miles away. The Perseverance rover, which is storing samples for later return to Earth, touched down on Mars as part of the Mars 2020 mission. It was determined that Perseverance will serve as the principal method of delivering samples to the sample retrieval lander due to its projected extended lifespan. In fact, one of its most important mission requirements was to help prepare for the Mars sample return mission. On 1 September 2021, we learned that Perseverance had drilled about 2 inches to extract a rock core. Once the piece was removed from the planet's surface, the sample was stored in a container. This was a historic moment for NASA and the scientific community because this marked the first time that a spacecraft had packed up a sample to bring back to Earth. In one way, the ambitious endeavor is already underway thanks to Perseverance's success in collecting the samples. At this point, we need to wait for the next few years for the concept to move into the technology development phase. The sample retrieval mission will begin in 2028 when 2 Ingenuity-class sample recovery helicopters and Mars Ascent Vehicle will be launched with the sample return lander. Both of these vehicles on board will be collecting samples with a tiny robot to store as backup. Then this rover and helicopters will transport the samples to the sample retrieval lander. The lander's own robotic arm will be used then to extract the collected samples and place them in the sample return capsule in the Ascent Vehicle. So, what is the Mars Ascent Vehicle? Well, it's a 2-stage, solid-fueled rocket that's almost 3 meters long and will be used to deliver the samples from the surface of Mars all the way to the Earth Return Orbiter. This Ascent Vehicle is currently being developed by Lockheed Martin when they were awarded the contract at the beginning of 2022. This Ascent Vehicle will be stored inside the sample retriever lander and will be covered with a protective coating to keep it safe during liftoff. For its return to Earth, the ESA developed a spacecraft that is expected to meet up with the Mars Ascent Vehicle to collect the samples it delivers. It is expected to launch in 2027 and arrive at the planet in 2028 when it will finally get to the proper orbit. On arrival, it will retrieve and seal the canisters inside an Earth entry capsule with the help of a robotic arm. The samples will be stowed inside the Earth entry vehicle, which will return to Earth a bit differently than other objects have. Instead of using a parachute to slow it down, the vehicle has been made with shock-absorbing materials. The samples will be protected from impact and land in the desert in the Utah Test and Training Range in 2033. Once the samples are retrieved, things don't get easier. Remember, we still don't know if there is life on Mars or not. Nothing's been confirmed yet. So the Mars sample return mission does have the potential to bring organisms back to the Earth and cause back contamination. Though the scientific community believes that the potential for any large-scale effects is small, they'll still have to be careful. In fact, all the samples will be treated as hazardous until the scientists can confirm that they are safe to interact with. In fact, on its return, One of the goals of the mission will be to ensure that the return vehicle has no contact with the Martian environment or even with the surface of the containers. If any organisms were released into the Earth's atmosphere, the U.S. would be responsible for any damages it would cause. Though the U.S. isn't the only one planning a Mars sample return mission, the Tianwen-3 Mars sample return mission has been announced by China. An orbiter and return module would be launched on a Long March 3B rocket and a lander and ascent vehicle on a Long March 5. According to their plans, they have the samples by 2031. Then there's France, who've been working towards a sample return for the last many years. This includes various ideas as well as concepts for an extraterrestrial sample curation facility for returned samples. They are focused on creating a Mars sample return orbiter that would collect and deliver the samples as part of an international mission. In 2015, the Japanese Aerospace Exploration Agency, JAXA, revealed that they had a plan named Martian Moons Exploration, MMX, that would collect samples from 2 of the planet's natural satellites. Phobos, the innermost moon, was chosen because it was closest to the planet and may have captured some particles from the red planet. They had planned the launch for 2024, which would return in 2029. The other moon chosen was Deimos, the outermost satellite, Russia's Mars sample return mission named Mars Grunt. Their design was pretty straightforward and was made up of an orbiter and a lander, which had a robotic arm connected to it to collect samples. This isn't the first time a mission of this kind has been suggested. Scientists have pushed for the retrieval of Martian geological materials for at least 3 decades. A sample collection for investigation of Mars concept was one early idea, and it called for sending a spacecraft on a grazing pass through Mars' upper atmosphere to gather dust and air samples without landing or orbiting. But there's a reason why the Mars sample return mission shows much more promise. In 2006, the Mars Exploration Program Analysis Group revealed that there were 55 important investigations to conduct on Mars. And 2 years later, they deduced that almost half of those investigations could be conducted with the aid of the Mars sample return mission. It would help make the most progress. Plus, another majority of questions couldn't be answered if the scientists didn't have access to any samples. Scientists can use a variety of cutting-edge lab technology that are otherwise too large and complex to go to Mars. So the samples can be evaluated when they're back on Earth as opposed to delegating the task to a rover on the Martian surface. Additionally, they can do investigations in the lab much more quickly while revealing a lot more details about whether life has ever existed on Mars. And let's not forget, if this mission was a success, it'll only help us gain a better understanding of the rest of our solar system as well.